Hi guys, Miss Pollock here. What I'm going to do is I'm going to take you through a quick revision of the majority of the concepts that we covered, definitely the concepts that we covered throughout the term last term, because you're going to be sitting for me a really a bit of a blitz quiz to see what you know and what you remember from last term. So before we get started, I'll take this one away. Let's have a quick look at the topics that will be on your quiz. So the topics on your quiz are going to be rational and irrational numbers, adding, subtracting, multiplying and dividing integers, applying order of operation, BIDMAS, simplifying algebraic terms, adding, subtracting, multiplying and dividing, the application of distributive law, factorizing, solving equations, and graphing a linear equation. So let's move through these. Okay, so looking at rational and irrational numbers, we know that we have a number system and we have non-real numbers or unreal numbers, and we have real numbers. So our number system is made up of real numbers. Inside of real numbers, we've got two types of numbers, rational numbers and irrational numbers. Our rational numbers are numbers that are terminating, which means they come to an end. Or they are recurring, which means they have a series of numbers or a number that is repeated continuously. So let's have a look at what a terminating number might look like. And a terminating number might look a little bit like 8. 8 is a terminating number, so the number comes to an end. It could also look like 3.12. This is also a terminating number because it comes to an end. What about 1004.3167? This is also a terminating number because it comes to an end after the fourth decimal place. So these guys here are terminating numbers, and they can be whole numbers or decimals, doesn't matter. And they sit underneath the rational number category. What if we have recurring numbers? These guys here, recurring numbers, is when we have a number or a series of numbers that are repeated forever. So what these might look like might be 19.1 recurring. We write that with a one on top, dot on top. And the dot on top just means that that one goes forever and ever and ever and ever and ever. So that one, that 0.111111 would keep going and going and going. This could also look like 0.45. That means 0.4545454545. So I'm going to write that in here so you can see that 0.454545. ... So it goes on forever and ever and ever. These ones here are recurring numbers. Rational numbers consist of terminating numbers and recurring numbers. Our irrational numbers, they do not terminate, which means they go on forever. Similar to these guys over here, only thing is they don't have a number that is repeated, and they don't have a series of numbers that are repeated. So there's no repetition forever and ever going on here. They do not end though. They also don't recur, and they go on forever and ever and ever. So some examples of these guys might be pi, 3.14 blah 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 blah, and it keeps going and going and going. Another example of this one might be a third. If you put that in your calculator, you'll get a decimal point that will go on and on and on forever without any pattern to it, or any recurring a recurring number or series of numbers that repeat again and again and again. So that is our quick summary of rational and irrational numbers. Time to move on. Okay, let's have a look at integers. When we're talking about integers, we are talking about, I'm going to grab a different colored pen. We are talking about whole numbers. Now, whole numbers, that can either be positive or negative. So, whole numbers that are positive or negative. Now, when we're looking at integers, we're looking at how we can simplify them or solve questions using integers, and we're going to look at how we can work with them in two ways. So the first way we're going to look at is how to add and subtract, and add and or subtract integers. When we're adding or subtracting integers, there is a rule that applies. When there are two signs next to each other, if the signs are different, so a positive and a negative, or a negative and a positive, and don't forget that this sign here means add, it means plus, but it also means positive, and we can use them interchangeably. So if we have an add and a take, or a positive and a negative, or an add and a negative, it doesn't really matter how you look at it. When the signs that are not, if they're right next to each other and they're different, this sign here becomes a negative. So we circle them and it becomes a negative or a takeaway. So when the signs are different, it's a negative or a takeaway. If the signs are the same, two takeaways, two negatives, a negative and a takeaway if you want to say it that way, and two positives, the signs become a positive. We'll get rid of that extra S there. Not sure why I've got it. So what we would do in this situation is we would circle two signs that are next to each other that are the same, and we make them a plus. Same with these guys here. Circle the two and we simplify them down to a plus. All right, that there is the rules. Let's have a look at how they look in practice. So my first example, I've got -3 take -7. In the middle, I've got two signs, so I need to simplify that out first before I can do the question. Two signs that are the same signs turn into a positive. So I'm going to swap that one there, those two, for a positive. So now I have -3 add 7. So -3 adds 7. If I'm adding 7 from -3, I'm going to move up to 0 and then keep moving past 0 all the way up to +4. Let's have a look at the next one. 4 add -6. I've got two signs again in the middle. So I'm going to circle the two in the middle. And I'm going to go, the signs are different. So different signs means it's going to swap over to a negative. So we'll exchange it and we'll get a negative. 4 take away 6. 4 take away 6. 6 is larger than 4 and we're going in the negative direction. So 4 take away 6 is going to be -2. That's adding and subtracting integers. Let's have a look now at multiplying or dividing. These guys here have a very similar rule, but it's just that little bit different. With these ones, when the signs were different, we exchanged those signs for one sign. In this one, when we have the same signs or the different signs, we follow similar rules. Only thing is the answer is what becomes either positive or negative depending on the signs. So we don't swap the signs in the question, we actually change the sign in the answer. So I'll show you what that looks like in a second. If the signs are the same, just like in this situation, the answer will be positive. If the signs are different, the answer will be negative. So key thing there is the answer will be positive or the answer will be negative. In this one here, changing that sign over doesn't necessarily mean that the answer will be positive or negative. All right, so let's have a look at this. -3 times -7, we do the multiplication as normal. So 3 times 7 is 21. And a negative times a negative, signs are the same, so the answer will become positive. +21. In the next one, we've got 4 times -6. So we're going to do this the exact same way. 4 times -6, 4 times 6 is 24. 4 is a positive, even though it's not shown. 4 is positive, 6 is negative, so a positive times a negative, the signs are different, the answer will become a negative. That there is working with integers. 2 rules, one for adding and subtracting, one for multiplying and dividing. Let's quickly show you one for dividing though before we go and move on to the next one. If I've got, so example number 2, if I've got -12 divided by +4, I do my division sum as usual. 12 divided by 4 is going to be 3. And a negative divided by a positive is going to be a negative because the signs are different. Negative and positive signs are different. If I have positive 8, negative 8, sorry, divided by negative 2, 8 divided by 2 is going to be 4, and a negative divided by a negative is a positive. All right. Next one. Order of operation. Flying through them today. All right, let's have a look and make sure we can fit this on your screen. Order of operation. So this is where we work out exactly how we solve a question, especially when there is more than one operator in the question. So we follow our rules of BIDMAS. Now I've written it out slightly differently. It's not in one line, either vertically or horizontally, and that's because these two here, or these four I should say, are very special in the way that they function. So we'll start at the top and work our way down. B stands for brackets. So you're going to do your brackets first in any question that's got multiple operators in it. So we solve the brackets first. Secondly, we solve the powers. All right, so I stands for indices or index. So we're going to solve the powers. D and M are on the same line, which means they have the exact same, either one can go first, except for we have to complete them from left to right. So as if you read order of operation from left to right, you complete division and multiplication starting from the left and working your way to the right. So we'll write these ones in. Division and multiplication from left to right. And then down the bottom here we have addition and subtraction. And again, same process from left to right. If we had a subtraction first and then an addition, we would do the subtraction first because it is the one on the left. So addition and subtraction. All right, let's have a look. I'm going to show you how to work these out. Quick little note there, I've got written down, only solve one part per line of working. So let's have a look at exactly how much working out I should be seeing from you. All right, in this question, I've got -3, add 13, divided by -5 times -2. Now, you've got a very long vinculum here, and so that vinculum should have reminded you that if we've got a divide line that stretches across all of these numbers here are invisible brackets. So we know what we have to work out first. -3 plus 13 is going to bring us to +10. Now that's the thing that I'm going to work out in this line, so I have to go and copy out all the rest of the question before I move on to the next one. So that would actually get me a mark in my exam. Now I've got 10 divided by -5 times -2. If I have a look at the operators that I have left, I only have a divide and a times. Those guys there are on the same level, so I don't have, the one I have to do first is the one that's on the left. In this case, that's the divide. So 10 divided by -5 is going to give me -2, and I copy out the rest. Only one operator left, -2 times -2, a negative times a negative makes a positive, and 2 times 2 is 4. So working out one piece of the question in each line and making sure you work following your orders of operation. All right, last one on order of operation. This time we've got a few extra bits and pieces in here. We happen to have brackets, which are, I've drawn them in for you, but they don't have to be there if it's written like this. And we have got brackets, an addition and a subtraction, a divide line, an addition and multiplication, and a powers or an indices. So we're going to work in order using our order of operation. So the first thing I need to do is solve my brackets. -3 plus -12. I've got 2 signs in the middle. we need to circle them and simplify them down to 1. When the signs are different, it becomes a negative. Negative 3 take away 12 is going to give me negative 15. That's the one that I've simplified and worked out, so I'm going to put my divide line in and copy out the rest of the problem. After I've done this, now I have no brackets remaining, and the next most powerful thing I need to check for is if there's any powers. I can see that I've got powers here, so that's the bit I'm going to work out next. So 2 to the power of 2, or 2 squared, means 2 times 2, and 2 times 2 is 4. So I write that in, and then I copy out the rest of the line again. So negative 15 divided by 3 plus 4 times 4. Now I look at my operators again. I've got a divide, an add, and a times. My division and my times have the same strength, but again I have to work from left to right. So the one on the left is negative 15 divided by 3. Negative 15 divided by 3 is negative 5. I copy out the rest because I've just worked out a piece of the problem. Now the next thing I need to look at is again my operators. I have an addition and a multiplication. I have to do the multiplication first because that is more powerful than the addition. So positive 4 multiplied by 4 is going to give me 16. Copy out the rest. And negative 5 plus 16 is going to answer as positive 11. So many steps in this one here, but making sure that we show all of our working so that we can get all of the marks, particularly if we make a silly mistake somewhere throughout it. Okay. Simplifying algebraic terms is where we're heading to next. And what I'm going to do is I'm going to get us to focus only on a piece of it at a time. So I'm just going to keep this bit covered as we go. We'll show a little bit more of it. So simplifying algebraic terms means, simplifying means to make smaller. So simpler or smaller. In this situation, I need you to remember that terms are separated by add and subtract signs. You need to remember what your terms are and you need to be able to identify them. So terms are separated by add and subtract signs, and the sign in front of the term belongs to the term that comes after it. So what that means is that if I've got something like negative 4a plus 3x, that sign there tells me that that's the gap between this term and this term, and that positive sign belongs to the positive 3x and the negative sign belongs to the negative 4a. So I have two terms written down there. The other thing to note is that when you have terms and you remember to keep that sign attached to them, you can actually reconfigure these in any way. So this is exactly the same as writing positive 3x take away 4a. Exactly the same, because that has now moved there as an entire puzzle piece, and that has now moved there. So once you've got your terms worked out and you know how to separate them, you can move them and reconfigure them as it is convenient. So let's have a look at adding and subtracting algebraic terms. Key thing here, if we're adding and subtracting, you can only do this to like terms. Now, adding and subtracting is the only one that's this fussy. Must add and subtract like terms only. So if I have a look here at what I've got, I need to first, step number one is identify my like terms. I'm just going to swap pens so you can see what I've done to the question and where the question ends. 2a squared b, take away 3b squared, take away 3a squared b plus 5b squared. In this question, well, let's have a look at to identify the like terms, we have to have the exact same letters and powers. The number in front can change, the sign at being positive or negative can change, but these letters and powers have to be the same. So I can see already that 2a squared b is a like term with negative 3a squared b. Make sure you circle the sign in front because it belongs to that term. And then I can also see that negative 3b squared is like terms with positive 5b squared. So what I'll do is I will chuck in a different shape around them. In my next line of working, what I'm going to do is I'm going to write my similar shapes next to each other. So I'm going to write down 2a squared b minus 3a squared b minus 3b squared plus 5b squared. So you can see that I've got my 2a squared b, my negative 3a squared b, negative 3b squared here, and positive 5b squared here. Circles together, rectangles together. Now for our last line of working, if I have 2a squared b's and I take away 3a squared b's, I'm going to end up with negative 1a squared b's. Now quickly, let's remind ourselves, if I have 1 or a negative 1 of something, is it the same as having just a negative a squared b? And the answer is it is. So we don't usually write anything with a coefficient of 1. All right, so the number in front is never ever a 1. If it is a 1, we simply remove it. Now I've got negative 3, so don't forget that negative belongs to this one here. Negative 3b squareds, and we're going to add 5b squareds, so I'm going to get positive 2b squareds. And that question has now been simplified. Let's have a look at multiplying. Okay, multiplying algebraic terms is perhaps probably the easiest one out of all of them. When we do this, we follow some very simple rules. We multiply all of our numbers as we normally would. We write our letters out in alphabetical order, and then we simplify them using powers. So let's have a go. Negative 2 times 3 is negative 6, and negative 6 times 2 is negative 12. Negative 2 times 3 is negative 6, and negative 6 times 2 is negative 12. Now we need to write out our letters in alphabetical order. So I've got a squared, a, b, b, and c. Now you know that a squared equals a times a. So that means that I've got a squared, a times a again. So when I write this out and I simplify it, I end up with a squared times another a is going to give me a cubed, or a to the power of 3. Two b's multiplied together can be simplified to b squared, and then c on the end. That is how you multiply algebraic terms. We're going to come back to this one in a second. But first, actually, we'll come back to division afterwards. We'll do factorizing first. Okay, so we know how to multiply algebraic terms. What we're going to do now is I'm going to teach you how to put this into practice when it comes to, not factorizing, I take that back, when it comes to distributive law. So when we do distributive law, this bit here has all been talking about simplifying and making things smaller. In distributive law, we tend to make things a little bit bigger, but by doing it, it means we remove the brackets from the question. So it opens it up and enables us to do usually something else in order to solve the question. So in distributive law, I'll quickly remind you, we're going to expand the expression and remove the brackets. Okay? And in the process, the term on the outside is multiplied by all the terms on the inside of the brackets. So to show that, I'm going to draw some arrows. So firstly, we're going to write down 2a multiplied by 3ab. The next one is going to be 2a multiplied by negative 4c. So we'll put in a plus sign because plus 2a, positive 2a. 2a multiplied by negative 4c. Then we'll go and put in our last one, 2a multiplied by positive 2a. Now 2a is positive, so I have to put in here positive 2a multiplied by positive 2a. can you see that we have got, we've multiplied each thing inside the brackets by the term on the outside the brackets. So 2a times 3ab, 2 times 3 is 6. A times a is a squared, and b goes on the end. Positive 2a times negative 4c, positive 2 times negative 4 makes negative 8. A times c is a c. And positive 2a times positive 2a, positive 2 times positive 2 equals positive 4, and a times a is a squared. So distributive law, we're removing the brackets and we are multiplying every term on the inside by the one on the outside. Let's quickly jump across to factorizing. Okay, so factorizing, and I'll bring over my distributive law one more time actually. Factorizing is the exact opposite to distributive law. So in distributive law, we are taking things out of brackets. In factorizing, we're putting them back into brackets. So if you see factorizing and you can't remember what it is that you're going to do, factorizing and distributive law, complete opposite. To do this, what we do is we put our line underneath the addition or the subtraction sign. If you have more than one, you put more than one line down. Underneath this, we're going to put a plus sign straight away and draw in our brackets because we know we're putting this back into brackets. Then what we're going to do is we're going to have a look at our numbers. So I've got a positive 3 and a negative 6, so don't forget where that negative belongs to. I need to think of the largest number that goes into positive 3 and negative 6. So I know positive 3 and negative 6, the biggest number that goes into both is going to be positive 3. Once I know that, I need to think to myself, what times positive 3 will give me positive 3? And the answer is 1. What times positive 3 will give me negative 6? And the answer is negative 2. Negative 2 times 3 is negative 6, and 1 times 3 is positive 3. After I've done my numbers, I'm going to look to the letters and I'm going to expand them. So if I have x squared, it means I have x times x, and then I have a y as well in this term. So on this one here, write out my letters and expand them where there's powers. So I have a, x, y, and it's y squared, so another y. After you've done this, all you're going to do is circle everything that's similar on both sides, or matching on both sides. So this 3 matches this 3, and this x matches this x. So I write one copy of the matching in front of the brackets, and everything else that's not matching inside the brackets on its own side. So I have 1xy and negative 2ay squared. So two things to fix up here. I have two signs in the middle, so I'm going to cancel that out. They're not matching, so it's going to become a negative or a takeaway. And I also have a 1 here, and I know I don't need a 1 in front of a term. So that there is factorizing distributive law and simplifying algebraic terms. Let's have a quick look at division. In division, we have got 3 main ways of dividing algebraic terms. We've got a way that we use when we divide numbers evenly. When the numbers divide evenly, sorry. We have a way that we use when the numbers do not divide evenly, and then we have a way that we use when we have more than one number or more than one term being divided by a number. So in this one here where the numbers divide evenly, so we'll have a look at this one here first. The first thing I do is I put an equal sign down and I draw in my vinculum. I look at the numbers and it's always the top one being divided by the bottom one. So on the top line I've got negative 9 and on the bottom line I've got 3. So I know that 3 divides into negative 9 evenly, and it divides in negative 3 times. So I write that on the top line because 3 divided into negative 9, negative 3 times. I then expand all my letters. So a squared turns into a, B and C, and on the bottom line I've already divided my 3 up, so I have only got A and D left over. Anything that matches now on the top and bottom line will get crossed out. So I have two A's on the top line, but I've only got one A on the bottom line, which means only those two will cross out. After that, there's no D's on the top line, so that is my answer. The answer to this question is -3 ABC divided by D. And that's the answer for when these can be divided evenly. If the numbers cannot be divided evenly, we have to look for a highest common factor. So remembering, first step I'm going to do is going to put my equal sign down and draw in the vinculum. I'm looking at my numbers. 8 divided by 24. I can't divide 24 into 8 evenly. So what I'm going to do is think of the highest common factor that goes into both. The biggest number that I know that goes into both is actually 8. So I'm going to divide both of those numbers by 8. 8 goes into 8 one time, and 8 goes into 24 3 times. Now that I've divided the numbers, I do the same process as what I did over here. I expand my letters. So on the top line, I've got A, I've got E to the power of 3, so I'll have 3 E's and a J. On the bottom line, I've got A squared, so I will have 2 A's and an E. I cross out everything that matches on the top line and the bottom line. That would be 1A with 1A, 1E with 1E, and whatever's on the top line, and the bottom line, I rewrite where they belong. So 1, EEJ, I know that I don't need the 1 there. So E to the power of 2, J, divided by 3A, because that's all that's left on the bottom line. And in the very, very last one for division, when there are 2 terms on the top line that are being divided by the bottom line, the rules are quite simple. To cross something out or to divide it evenly or to find the highest common factor, it has to belong in every single term. That means that if I'm looking at my numbers first I'll draw in my vinculum because it's very important. I've got a 2, a 4, and an 8. So +2, +4, and +8. The biggest number, I know that 2 can't be divided by 8 evenly, and neither can 4. So particularly because 8 is bigger than both of them. So what I need to do is I need to work out what the highest common factor is that can go into all of them. So what's the biggest number that divides into 2, 4, and 8? Well, 2 happens to be the smallest number on here, which means the number that divides in can only be as big as 2. And 2 divides into 2 evenly, 2 divides into 4 evenly, and 2 divides into 8 evenly. So I'm going to go and simplify all of these by dividing by 2. So 2 divided by 2 is 1. +4 divided by 2 is going to be +2. And 8 divided by 2 is going to be 4. After I've done that, what I'm going to do is expand all my letters again. So I've got B, B, C, B, B, E, and A, B, B. Alright, the last step is to cross out everything that matches in all 3 terms. It can't just match in 2 of them. So what I'm going to do is I'm having a look. I've got 1B here, 1B here, and 1B here. And I have another B here, another B here, and another B here. I don't have an A that exists in all of them. I don't have an E that exists in all of them, and I don't have a C that exists in all of them. So the number, or the answer to this question is 1C plus 2E divided by 4A. And we know I don't need that 1 in front of the C because it already is 1C without the 1. Okay. Solving equations. What I'm going to do is I'm going to hit pause here and I'm going to get you a second video for this one.